Hello guys, I would like to start a new video series about AP Chemistry free response. The AP Chemistry free response have 7 questions. Usually this section takes 90 minutes and accounts for half of your AP Chemistry score. As you can see, this is a very important exam, and I will try to help you and by commentating about helping how to explaining how to solve those questions. So I'm going to start from 1999. That's the oldest public test that could be found on collegeboard.com, and I would like to go from 1999 up until last year. So let's get started. So on question 1 of 1999, well, we have a acid and base test. Question. So on the first part, write the equilibrium constant expression for the reaction represented above. So since the question is a base, as you can see, it dissolves into OH. It forms OH minus with water, ammonium. That's ammonium, as you can see. So the equilibrium constant is represented by Kb. So therefore, let's solve the question. Kb equals, for the equilibrium constant of acids and bases. Whoops, wrong window. So for the equilibrium constant for the acids and bases, it is reactants over products. Notice that only aqueous solutions gets in place in the equation. So H2O does not is not in the part of the equation. Only NH3, NH4 plus, and OH minus is. So NH4 times the concentration of NH4 times the concentration of OH minus. Whoops. Divided by the concentration of NH3. So this is the first part. So the first part should be an easy grade for you. For the second part, it asks you to calculate. Let me close that window. It asks you to calculate the pH of 0.0180 molar NH3. Since NH3 is a it's a weak acid, we need to find the concentration of OH minus, but however, OH minus is kindly given to us on this problem. So it's 5.60 times 10 to the negative 4th. So we're going to find the pOH of that by by taking the negative log of the OH minus, which is 5.60 times 10 to the negative 4th. This yields a result of 3.25 pOH. To find the pH, simply subtract the pOH from 14, which yields an answer of pH equals 10.75. It's a pH. Alright, that should be an easy point for you too. For part C, let's look at the portion. Let's just delete those. A, B. Alright, enough with those letters. For part C, to determine the value of the base ionization constant Kb for NH3. For that, first we're going to set up an ice chart. The equation calls for NH3. Let me just never mind. NH3. Let's see, NH4 plus. Since water is not a part of the equation, so we're going to omit water. So in the ice chart, of course. OH minus. Alright. So I, C, E. So the initial value for NH3 should be let's see, 0.0180 molar. For both NH4 and OH, since at the initial point of the reaction there is none produced, so we're going to put it at 0. So at the final, so in the final solution, the OH minus concentration is 5.6 times 10 to negative 4th molar. So because of that, on the C step, we write we minus 5.4 times to the negative 4th. And on both NH, since it's due to stoichiometry, NH4 and OH minus both increases 5.4 to 10⁴ molar. 10 to negative 4th molar, which is a pretty small value. Alright, so for the final concentration, we get 0. Let me get my calculator. So for the final concentration of the part, we get 0.0180 minus 5.4 to 10 negative 4th, which gives us a value of 0.1746 molar. I repeat, it's 0.01746 molar. Due to the significant figures, we can only have 3 digits at the time. I mean 2. So we're going. So this is 0.01746 molar, and we're not going to do significant figures then on this step because we're just gonna do it on the final step. For the NH4 and OH minus, both is 5.4 to the 10 negative fourth molar. Alright. Now, for the next, and we plug this into this equation at Kb equals NH4 blah 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 divided by NH3. And I'm just gonna throw out the Kb values because everything is self-explanatory at this point. 1.80 to the 10 negative fifth due to two significant figures. Alright, up until this step, it should be pretty easy to solve. Everything is easy for A, B, and C usually. Alright, for the next part, we got determine the percent ionization of NH3 and 0.0180 molar NH3. So for that part, we are going to divide 0.0180 molar NH3 by we're going to divide the concentration of OH minus by the initial value of NH3, which is 0.0180. Percent ionization (FRI) is that how much of the of a molecule that had been dissolved, which is changed to ions in water or some other similar solvent. So we're going to do that, and so since it's just simple division, it is just 5.6. So it is just OH minus divided by NH3. Divided by, double check it, and yeah, that's correct. So the answer for that, according to my calculator, is 0.0311. Since it asks for percent, we just need to times it by 100%, which yields 3.11% ionization. Pretty easy. So for the last part of question 1, up until D, everything has been pretty easy. Then in E, this is usually the hardest part of one free response question, but usually it should not be too difficult. So in part E, in an experiment 20.0 milliliter, which is 0.020 liter sample of 0.0180 molar NH3 is placed in a flask and titrated to equivalence point and beyond using the 0.0120 molar HCl. So for titrations, you should let me open Paint so you can see better. So usually for a titration, so on a titration curve, the equivalence point is where it's in the middle point. This is a point where all the H2O, I mean the acids and bases like neutral, is all like neutralized at this moment. So all the bases are consumed by the acid. So for the question, so we first need to determine the volume of 0.0120 HCl that was added to the equivalence point. So we first need to find out the NH3 ion. So we multiply the 0.0180. Let me get word out. Part 1, 0.0180 times this equals equivalently 3.6 e negative 4 NH3. So the equation looks like this. The acid base. The equation looks like this: NH3 plus H plus equals, yields NH4 plus. So since we found out how much NH3 is needed to get the NH4, we could get the H plus constant via stoichiometry, which yields us the same value as at NH4 moles. By the way, that unit is in moles. Whoops. So moles H plus. Because of that, we can now determine the volume of 0.0120 mole HCl. So since we found M equals moles, the concentration equals moles divided moles solute divided by moles volume solvent solution. Sorry about that. We can manipulate this function to calculate the volume of solution, which is so we could manipulate it so that we could divide so we could divide moles by we could divide moles by the molar mass to the concentration to get the volume. So we do that right now. Negative fourth divided by NH3. Hold on. Yeah. So yeah, it's molar. Okay, good. So we got 0.030 liters. Convert that into milliliters, which is 30 milliliters of HCl solution. Then we need to find the pH of the solution in the flask after a total of 15.0 of 0.0120 molar HCl was added. Now, so this is a titration curve, right? So since as mentioned in the previous problem, 30 milliliters of HCl is required to get the titration point. The equivalence point. Now, since it says 15, it does not equal to the it is not the equivalence point just yet. So we're going to explain that right now. Yes. So back to the problem. Benny Kim just cut it off because I didn't register. I'm using a free version right now. So we're going to do that. Let's see. According to my calculations, added. So the added H plus is so the added H plus in the solution is 0.0120. That's the amount of moles. That's the molar is the solution times the 0.0150 liters of the solution. We got a 0.00018 moles of H plus ions. I mean of HCl. Since HCl is a strong acid, that means it ionizes completely in the solution. Where this yields 0.00018 moles of H plus ions. Now, since that is equal to 0.000, since that much 0.00018 moles of OH minus is cancelled out in the process. Therefore, 0.00018 moles of OH is cancelled out in the process. Now we need to find the concentration of NH3 so 0. Since this is 0.0, which OH minus is you can calculate NH3 from OH minus divided by 0.335 equals 0.0514 molar NH3. So this should be equal to NH4 concentrations due to stoichiometry. Alright, so for that, since we got the KB already in part B, right? In part C, right? So we're going to divide 1.8 to the 10 to the negative 5 equals that equation. Let me just copy and paste. Great. So since this is the equation, since NH4 equals NH3, it should just cancel out each other out at this moment. So OH minus should be equal to sorry, I didn't explain. I don't think I explained why is it 0.035 liters. This is because the volumes are additive plus equals part of B liters. So that's for the clarification of this thing. So OH minus equals 1.8 to the 10 to the negative 5th, which POH is pretty self-explanatory. Which we got 4.74 for the POH, and pH. I'm gonna write it out step by step. Is equal to 9.26. Now last part we spent. So for the last part, determine the pH of the solution in a flask after a total of 40 milliliters of 0.0120 molar HCl was added. So so 40. So that's after the So following the equivalence point. So that's after the equivalence point. So at that point, all the OH minus ions in the solution would have to be consumed. So the acid is just piling up. Alright, so yeah, so it just piles up, making the solution more acidic. Alright, so since let's see. So in the 40 milliliters of HCl added, we got 0.0120. That's the molar times 0.040 liters of the solution, which yields at 0.00048 mHCl. Since HCl is a strong acid, we could just go right to the H plus concentration. Now because we calculated the an amount of H plus required to reach equivalence in part 1, right? So it requires 3.6 to the 10 to the negative 4th moles of H plus. So we're going to minus 0.00048 minus 0.00036. That's 3.6 to the 10 to the negative 4th, which equals to 1.00012 moles of H plus. Divide that by the total volume we got the total volume this time is 0.06 because the solution is 0.020 plus 0.040 equals 0.06. Let's see. So we just find the molar the concentration of the H plus, which is 1.2 e negative 4 divided by 0.06 equals 0.002 molar H plus in the solution. To find the pH, just take the negative log of the set number, which gives us a value of 2.70, which is a pretty low pH value for a solution. So I'm going to continue on with part 2. Okay, this is question 2 of 1999. So sometimes on the AP questions, they ask you to answer either of question 2 or question 3. So they ask you to choose a question. So question 2 is about a electron chemistry type question. Question 3 is a rate law type question. So for that, please choose the easiest question you would like to do. For me, the rate law question is more easier and more straightforward than the electron question, but I did both just for the sake of explaining. So let's get started on number 2. So for number 2a, the longest wavelength of light with enough energy to break the CO-CO bond in CO2 is 495 nanometers. So first, we need to calculate the frequency in S-1, also known as Hertz, of the question. Let me get my book. Let me get my experiment. Alright. So so for that one, we will need to use C equals lambda mu lambda, in which lambda is I don't see a lambda button. I don't know how to type that. So I'll just substitute that with this symbol, 2 slashes, and so v is mu then. All right. So c equals lambda mu, where lambda is a wavelength. So let me annotate it so you guys know what is going on. Meters. Mu, this is the V looking sign on printed paper. Mu should be in hertz. Hertz, which is measures of frequency. So of the light wave. Since light wave have a constant of 3.3 to the 10 to the light speed is a constant for all electromagnetic wave, so which is the speed of light, 3 times 10 to the 8th, 3e8. So now the question wants you to solve for the it gave you the wavelength and we already know how much light travels. So we just need to find the frequency. So we just need to divide c by wavelength. All right. So c divided by wavelength equals 3.00 to the 10^8 divided by, it gave you a number in nanometers, so be sure to change that into meters. So it yields 7.95 to the 10 to the -7. I'm just gonna write scientific notation because the number is ridiculously big. All right. So we yielded a v. I mean the frequency of 6.06 equals 6.06 to the 10 to the 14th. Hertz, which is s-1 in this manner. So this is basically plug and chug, not too major here. So for the next part, we got calculate the energy in joules of photons of light. For this one, you need to know the you need to know the E equals hv. H, I mean the H mu equation, which E stands for energy in joules. HV. So E is in joules, right? E is in joules, the standard unit of energy. H is the Planck's constant, which is a constant associated with electrons. So its unit is 6.63 to the 10 to the -34th. It does have a unit. It is measured in joule seconds. Now, so to find the V, simply divide E by the Planck's constant. And for that particular one, we hold up. Whoops. It finds we are supposed to find the E, so yeah, we're supposed to find the E for that. Sorry about that. So we need to find the E in joules. Now, We found the wavelength already in the last problem, which is a 6.06 to the 10 to the negative fourth. I mean to the 14th power. Now we need to multiply that by the Planck's constant of 6.63 negative 34, which this yields a value, a value of, according to my calculations, we got 4.02 to the negative 19th joules. Alright, pretty easy. Now, for the last part, it is calculate the minimum energy in kJ moles per mole of the CO bound. So for that one, it is in kilojoules, right? So the total energy, let me write 3, that's 2. Just for the sake of easiness of identification. Alright, so for that one, we need to calculate the minimum energy in kJ mole per mole in the CO bound, right? So we already got the let's see. So we already got so the energy required to break up the bound is 4.02 times 10 to the negative 19 joules, which so since we need to find the per mole thing, so let me use the units to see what's going, so you guys can see what's this going on right now. So we could do 6.02 times, so that's the Avogadro's constant of per mole minus 1. And since it comes out in joules per mole, we need to make it into kilojoules per mole. So we times we divide by let's just by 1 times 1 divided by, that sounds it. So, okay, so we got it. Alright, so we got a result of 242 kilojoules per mole. Now part A is pretty easy. Now on to part B. Part B is slightly a little bit harder, but still it's the same knowledge about the electrons, I guess. Now we are going to do that right now. So part B, let's start a new one. Indicate whether okay, so we need to indicate whether the Hi atom emits energy or whether it absorbs energy during the transition. Justify your answer. So for that one, we need to it's a explanation problem, no calculation required, but you need to explain it with decent knowledge. So my explanation is that it emits the energy, so not the energy. It emits energy because because the electron transits from the electron falls from a higher energy state, which is n equals 6, to a lower one. So as n number increases, the energy increases. Now because of that, because that must the electron must lose energy. Okay, so we got n equals 4. Okay, so we must lose energy, which it emits. That one is pretty straightforward. Now we need to calculate the wavelength in nanometers of the radiation associated with the spectral line. So I'm going to introduce a new equation in this thing, in this formula. So E of orbital is equal to divided by n2, n times n2. All right, so we need to find the energy of the 6th orbital. Then we need to find the one of the 2 orbital. Then we need to find the energy differences in between, so we could calculate the frequency based on E equals hv, and eventually wavelength based on C equals lambda mu. Okay, so let's go then, I guess. So E6 equals negative divided by 6 to the 2nd power. Let me use my, so for that we yielded a value of since the values are negative, so values are negative, so we need to minus the take the bigger value, the smaller value, this subtracts to a bigger value. So it's E2 minus E6 equals negative 2.178. E18, do the same thing for E2, equals calculator. So we subtract E2 with E6, which rounds out to the total energy emitted, which is currently calculating right now. Hold on. So for that we got negative 4. We got let me see. We got 4.84. Sorry about that. I just need to look up the answers just to be sure. Okay, 4.84 E negative 19 joules. So based on that, we could calculate the V. I'm not going to do the specifics because it's pretty self-explanatory. By this point, which is we got V, we took that. Hold on. E divided by 8. So we just need to divide the Planck's constant by energy. Planck's constant which is 7.30 to the 10 to the 14th, and we could just find wavelength with the c equals lambda times mu equation. Lambda, just that poorly drawn symbol. Now, so 3e18, 8 divided by so we got 4.1011 times 10 to the negative 7 net meters. Since it wants it to be in nanometers, we convert it to 4.1 nanometers. Alright, next up, so for the final one, it's about electron. So it's about periodic trends type a little, about periodic trends and how it affects electrons. So my explanation is that the He atom so for any AP exam you need to list all the values and such. It will help you, especially when comparing each one. Atom nucleus, sorry about that. Therefore, He exerts a greater force which increases Bandicam is about to run out. Alright, back to the question. Sorry about that. Sorry about the interruption. So therefore He exerts a greater force on the electrons, which results in a the amount of energy is associated with which in the observed difference in the transit, in a similar process. So that might not be the best answer to it, but just for your reference, you could explain it another way. That means the wording could be different. So that's just for your reference.